Okay, so this is for the overachievers who wanted their notes all filled in. Some of you requested it. So I've redrawn the graph. Might look a little different from the last page. And as a reminder, we are doing the shell method because h is parallel to the x-axis or perpendicular to the y-axis. I like to focus on the perpendicular. If it's perpendicular to y, I would be using dy. So I'll need my equations in x equals. And as you can see, I've already put my equation here in x equals. Okay, so now I've got to find the radius, and if you've noticed, I've drawn a bunch of these parentheses over here, or brackets, so that we can see what's happening with r each time. And of course, r is going to be equal to the top minus bottom. So the top is 1, because that's where every single one of those radii touch, is up here on y equals 1. And the bottom is just going to be some y value because the distance is always some y where it finishes up. Now, the height is really dependent upon where we are in the shaded region. If you notice over here, I marked these with a number 1 and a number 2. So I'm going to look at height 1 first. And that height with right minus left, well, on the right, it touches my curve, which is 1 over the square root of y. And on the left, it touches 1. If I look at height 2, on its right, it touches 4. And on the left, it also touches 1. So that height would be 3, which means I'm going to have to integrate in 2 separate pieces because I have 2 different heights. I'm going to set it up. So if you notice, of course, I have an addition going on here in the middle of it, and I have 2 separate pieces, but in both of those pieces, I have the radius and I have the height. Now, those are different sections, so I'm going to have to figure out the bounds accordingly. So in this front section, the bounds where I'm going to be hitting this particular height start at when x is 4. And when x is 4, that bottom value will be 1/16, just by substituting in 4 for x. And the top height of y will of course be when it hits that line, the spin axis y equals 1. Likewise, over on this right hand side, now I'm looking at when the height is 3. Well, the height is 3 from the same separator point down. And so again, it's from 1/16 on the upper part of it down to 0 on the lower part of it. Okay, I'm going to integrate. You do the same. We'll see if we get the same answer. I used a calculator to do both parts so you can see I have decimal answers, but here's my final answer. On to problem 4. So as you can see, I've drawn the graph. My height in purple parallel to my spin axis, which means it's perpendicular to y, so I'm using dy, and therefore I need my equation x equals, which is convenient because I already had it. Alright, so I'm ready to talk about the radius. Notice the radius is a top minus bottom, so it is y minus 0, and the height is a right minus left, so it is 1 plus y squared. So I'm ready to integrate. So I've set it up. Here's my radius, here's my height, and now I need to look at the boundaries. But if I look at the shaded region, the lowest y value is 1, and the highest y value is 2. And following through with all the integration here, I've showed my steps, and my final answer is 21 pi over 2.